There is a planet 124 light-years from Earth, covered entirely by a single global ocean. No land, no continents, no shore. Just water in every direction, stretching beyond every horizon a human being has ever imagined. And in 2023, the most powerful telescope ever built pointed at this one planet and found a molecule that should not be there. Dimethyl sulfide, DMS. On Earth, this molecule has one overwhelming source: marine microorganisms, phytoplankton, living things breathing it into the air in quantities so vast you can smell the ocean from miles inland. The smell of the sea, that sharp, briny, unmistakable scent, is dimethyl sulfide. And that molecule, that fingerprint of life, appeared in the atmosphere of a planet 124 light-years away. But here is what happened next. What followed was one of the most intense scientific debates of this decade, a fight over what one molecule really means. And the story of that fight tells you more about how science actually works than any textbook ever could. The planet is called K2-18b. It is 2.6 times the size of Earth, 8.6 times its mass, roughly halfway between Earth and Neptune in scale. And it orbits its star every 33 days. 33 days. Mercury, the fastest planet in our solar system, takes 88 days. K2-18b completes nearly 3 orbits in the time it takes Mercury to finish one. Its star is a red dwarf, cooler than our sun, dimmer, the kind of star that burns slowly and lives for trillions of years. And K2-18b sits directly in its habitable zone, the narrow region where temperatures allow liquid water to exist on a planetary surface. Kepler found it first, the broken telescope. In 2015, during its second life, the K2 mission, after its reaction wheels had failed and NASA had repurposed it using sunlight pressure as a makeshift stabilizer, it detected the faint dimming of K2-18's light. A shadow, less than 1% of the star's brightness, gone for a few hours. That was enough. But the real discovery came 8 years later. In 2021, an astronomer at Cambridge named Niku Madhusudan proposed something that sounded almost too specific to be true. A new category of planet. He called them Hycean worlds. Hydrogen-rich atmosphere above, ocean below. Temperatures at the surface warm enough for liquid water, possibly up to 200 degrees Celsius, but still liquid, still capable of hosting chemistry, still capable, perhaps, of hosting life. Hycean planets are not like Earth. The atmosphere is crushing, perhaps hundreds of times the pressure we experience at sea level. The ocean is deep beyond anything in our solar system. No land means no beaches, no shallows, no continental shelves. Just a seamless boundary between water and sky wrapping around the entire sphere. You could not stand there. You could not breathe there. The atmosphere has just enough hydrogen to kill you instantly, but not enough to make the planet a gas giant. It's in between. Like Mars has just enough atmosphere to burn you, but not enough to slow you down. K2-18b has just enough atmosphere to crush you, but not enough to become a star. And that balance, that narrow, improbable balance, is exactly what makes it the most interesting planet humans have ever studied. Now let me show you just how far away this planet really is. If our sun were scaled up to the size of Phoenix A, the largest known black hole, spanning about 590 billion kilometers, our own Earth wouldn't be nearby. It would orbit nearly 63 trillion kilometers away, more than 100 Phoenix A diameters from the Sun. Even light would need almost 7 years to make that journey. And K2-18b is far beyond even that, about 124 light-years from Earth. Every photon James Webb captured left that world before the First World War, before powered flight, before humans had ever left the ground. And after traveling through space for 124 years, we still detected the chemistry of its atmosphere from here. Here is how James Webb found dimethyl sulfide. Not by seeing the molecule directly, not by photographing the planet. As K2-18b crossed in front of its star, Webb captured the starlight that passed through the planet's atmosphere. Every molecule in that atmosphere absorbs specific wavelengths of light. Methane absorbs differently than water. Carbon dioxide absorbs differently than both. And dimethyl sulfide, DMS, leaves a signature that Madhusudan's team argued nothing else in the planet's chemistry could quite explain. The first hint came in 2023. Webb's near-infrared instruments found methane and carbon dioxide in a hydrogen-rich atmosphere. And buried in the noise, the faintest possible whisper of DMS. Barely there. Not enough to claim anything. So they looked again. This time with Webb's mid-infrared instrument, MIRI. And in April 2025, the signature returned, stronger. The paper was published. Madhusudan's team, Cambridge, the Astrophysical Journal Letters. The finding, tentative, but this time it reached 3 sigma, not 5 sigma. Not certainty. 3 sigma. 3 sigma means roughly a 0.3% chance the signal is a fluke, noise masquerading as data. In physics, you need 5 sigma to claim a discovery. 3 sigma is a raised eyebrow. It means something is probably there, but it's also exactly the kind of signal that has excited scientists before, and then, very often, vanished. The scientific community did what it always does. It pushed back. Hard. Independent teams at Oxford, Arizona State, and Chicago took the same data apart. They asked the question every good scientist must ask. What else could produce this signal? One answer was hazes, tholins, complex organic molecules that form when ultraviolet light strikes methane and nitrogen high in an atmosphere. Tholins can produce spectral signatures that overlap with DMS. They're common in our own solar system. Titan's orange sky is tholins, and they require no life at all. The magma ocean model proposed something even more dramatic. That K2-18b is not a water world at all. That beneath its hydrogen atmosphere lies not an ocean, but a sea of molten rock. And magma interacting with a hydrogen atmosphere could, in theory, drive sulfur chemistry, even DMS, with no biology at all. But then came 2 discoveries that changed everything. In 2024, scientists analyzing data from the Rosetta mission found dimethyl sulfide on comet 67P, a frozen, lifeless ball of ice and rock that has been drifting through space for 4.6 billion years. And it has DMS. And in early 2025, astronomers detected DMS in the interstellar medium itself, cold gas near the center of the Milky Way, in a region where no life could possibly exist. DMS was floating there, forming through pure chemistry, no organisms required. DMS is not unique to life. It never was. We just hadn't looked hard enough. The molecule we thought was the smoking gun turned out to be something far more complicated. A signal that life might produce, But life isn't the only thing that can. And then the detection itself began to crumble. Independent teams reran the same JWST data through more careful atmospheric models. And the DMS signal didn't hold. It wasn't statistically significant. Even a NASA-led reanalysis could push it no higher than a weak, inconclusive whisper. Worse, simpler molecules, ethane, ethylene, propyne, ordinary hydrocarbons, fit the data just as well. No clean biosignature, no confirmed DMS. None of this means K2-18b is dead. It means the signal was never as clear as the headlines suggested. It means science did exactly what it is supposed to do. It doubted, it tested, and it corrected itself. If DMS on K2-18b is eventually confirmed, if a future telescope sharper than Webb settles the debate, it would still be the most significant discovery in human history. Not the discovery of a new continent, not the discovery of a new planet, the discovery of a second Genesis, life arising independently, not related to us, not sharing our DNA, not sharing our chemistry, a completely separate origin, a second tree of life, growing in a global ocean 124 light-years away. It would mean life is not rare. It would mean the universe is not silent because it is empty, but because we have only just started listening. And Webb and its successors would keep returning to this one planet, observation by observation. Because this is not the kind of question you answer once and walk away from. This is the kind of question that defines centuries. So it's not that we found alien life on K2-18b. It's that we caught a scent on the wind from 124 light-years away. And we're still arguing about whether it was ever really there. Follow for more mind-blowing space facts.